A simple average helps you understand your actual return, but it doesn't tell you anything about the risk that you might be bearing. The variance and standard deviation is designed to help you measure that. The formula for return variance is calculated as follows. The first thing you want to calculate is the simple arithmetic return. That's that R with the bar over it. Then you take every single return and you subtract away the average return. Then, once you have each of those numbers, what are known as the differences between the average return and the actual return, you square each. Those squared values are then summed up. You divide by the number, but in this case, if you just divided by the number like you do with the arithmetic average, you'd be wrong. You actually have to divide the number minus 1. So in the last example, we had 77 in returns. We wouldn't use 77 to calculate the variance like we would with the simple arithmetic average. We'd have to use 76. That's because 77 minus 1 is 76. But usually, it's much more useful to use the standard deviation, and this is related to the variance in a very simple way. All we have to do is take the variance and use the square root. The square root of variance is the standard deviation. This is important because standard deviation is in the exact same units as the arithmetic return. So in other words, a percent value of standard deviation is comparable to the percent return, but variance is not because it's a squared value. Variance is a common measure of return dispersion, and usually we call return dispersion variability or volatility. Standard deviation, on the other hand, is the square root of the variance, and sometimes the square root itself is called volatility. So both variance and standard deviation measure variability, but standard deviation is handy because it's in the same units as the arithmetic simple average. The normal distribution is also a useful thing to think about. This is the symmetrical bell curve that you remember from high school. And this distribution can be described with just the average and the standard deviation. The thing that you want to think about is whether or not a normal distribution really describes asset returns. And we can answer that question just by taking a look at this frequency table on actual returns from year to year. Now notice that this looks like kind of a lopsided bell curve. In fact, most of the returns are over off to the right of the zero return line. And that's because the actual returns of stocks in the stock market is not exactly normally distributed. In fact, it's log normal. And the reason for that is that a stock can lose 100% of its value and no more. But it can make much more than 100%. In fact, it can make 2, 3, 4, 5, 600% returns in a year. And that forces the actual returns over to the right. This makes the normal bell curve look like a lopsided to the right curve, and we call that a log normal distribution. So the actual returns in the stock market are not normally distributed. They're not a bell curve. They're actually a log normal distribution.